Let's have a little look at this then. So firstly, let's have a recap of what we did last time, or if you haven't done this before, then this will be the stuff that you need to know beforehand. I want you to have a go at these, simplify these questions, however best you can. Do as many as you can in, say, don't take any more than 5 minutes. After 5 minutes, I want you to stop and then check it against my answers. Just make sure you do follow all the solutions, even for any that you might not have got to. Okay, so off you go. Put a little timer on. 5 minutes. Oh, and you need to pause the video as well, because now I've unpaused. There we go. Right, first one. Remember, if you're multiplying, you add your powers together. So the x will be the power of 12, because 7 and 5 is 12. And y will be to the power of 7, because that's y, so that's really y to the power of 1. So y to the power of 7. X here, now 4 times minus 3 is minus 12, or negative 12. And the x will be 2 take away 3, because it's 2 plus minus 3, so that's the same as 2 take away 3, which is minus 1. So you need to have the power of minus 1 up there. And we'll come to what that means today. Now x squared times by x squared make x to the power of 4. And y to the power of 8 times y to the power of 1 is y to the power of 9. Then minus 4 times 3 is minus 12 again, or negative 12. Y is minus 1 times by the 5. Well, not times 5, because it's times, we're going to add them. So minus 1 plus 5 is 4, positive 4. Okay, now we've got some algebra in the powers here, but that's absolutely fine. We'll just add together what we can. It's the same base numbers, 3, which means that when we multiply them, we can add the powers. And 3x plus 2 plus another 2 makes 3x plus 4. All right, so 3 to the power of 3x plus 4, and that's absolutely fine. Now, if you didn't know that and you stopped there, you might want to pause and have just a quick go at the next 2 or 3 before I show you the answers. Right, again, same base powers, or base numbers, so we can put 5 as that, and then add together these two things. So we've got the minus 2x plus 4 minus another 5x, so that would be 4 minus 7x, or, minus 7x plus 4. It's usually neater to put the positive thing at the front, though. All right, x, we've got minus 1 and a 4, which goes together to make the power of 3, so x to the power of 3, and y to the power of 5, because minus 2 and 7 makes 5. And last one, same base powers, or base numbers again, so we can add the powers. Minus x plus 5x makes 4x, because minus 1 plus 5 makes 4. And then minus 4 plus 3 is minus 1. So 4 to the power of 4x minus 1. Okay. So, negative and fractional indices. We'll do negative first, and then we'll look at fractional indices. So, fractions as powers. They're not quite as hard as you think. Firstly, what does this mean? Something to the power that's negative. Right. Well, it means this. 1 over 5 to the power of 1. That negative really means flip it. Or some people say push it down and make it positive. Push it underneath 1. And the power becomes positive. Now 5 to the power of 1 is just 5, so it'd be 1 over 5. That's what this means. Now I'm going to show you why, and show you sort of what the implications of this. Right, firstly, imagine we got 5 to the power of 3. It's separate to this, right? This is just a separate little demonstration. 5 to the power of 3 equals 125. Now 5 squared is 25, right? Because 5 times 5 is 25. 5 times 5 times 5 is 125. Well, to go from that to that, 125 to 25, we have divided it by 5. Same on this side, we've divided it by 5, which has reduced the power by 1. And we can do that again. If I divide it by 5 again, it will be now 5 to the power of 1. And over here, 25 divided by 5 is 5. So it all still equals, right? So we know this definitely works as a pattern. So if I divide by 5 again, firstly, my power reduces to 0. Now this proves as well, get two things here. This proves that anything to the power of 0 is going to be 1. Well, certainly 5 to the power of 0 is 1. Because if I do 5 and I divide that by 5, I get 1. Each time I'm just from one layer to the next, I'm dividing by 5. So the next thing is, if I divide this by 5 again, I will then have 5 to the power of minus 1. My power is reduced by 1. And of course that makes sense on this side, because 1 divided by 5 is 1/5, 1 over 5, right? And again, I can do that one more time, which is 5 to the power of minus 2. So I've divided by 5 again. This will be 1 over 25, which is the same as 1 over 5 squared. So that's what this means. If I've got a power that's negative, basically put it underneath 1. Oh, the dog's barking because the dog loves these fractional and negative indices. Hold on, I'm just going to mute my mic and shout at the dog. That's fine. Oh, and see, he's stopped now. He's a very obedient dog. Anyway, right, so the negative has pushed my power underneath. So it's now 1 over 5 squared, which is, of course, 5 squared is 25. Okay, so the negative, push it down, make it positive. 1 over my number, and the power now just becomes a normal power, and I can do what I normally do. Okay? Oh, I didn't realise that was there. Let's get rid of that. Let's erase that. It's a bit messy, isn't it? That's neater. Okay, and back to my pen. So this is the basic rule. If you've got something to the power of that's negative, put it underneath 1 and change the power to positive. It's the reciprocal. Okay, that's what we're doing here. We're finding the reciprocal. Right, in which case, just have a go at these then. I want you to write these as fractions, but without any powers in, okay? I want you to sort of simplify them so they don't have any powers. And over here, they're already written like this. I want you to write them in index form, so something to the power of minus something. Okay? Right, pause the video. Off you go. Okay, we've unpaused. And the dog has unpaused. Pause. A little bit of a dog pun there. Pause. Yeah. So 8 to the power of minus 2. Push it down, make it positive. 1 over, we're finding the reciprocal of this, and now the power is positive. And 8 squared is 64, so it's 1 over 64. Right. 4 to the power of minus 3. It's a negative power, so we'll do the reciprocal. Push it down, make it positive. 1 over 4 to the power of 3. Okay, so it's the same numbers here, same 4 to 3, but instead of the negative has like been used up by finding that reciprocal. And 4 cubed, we all know, is 64. 4 times 4 times 4. Again, we've got a negative power, so push it down, make it positive. We're finding that reciprocal. Okay, so 1 over 10 times 10 times 10 times 10 is, there's 4 zeros on that, so it's 10,000. 8 to the power of minus 1. Push it down, make it positive. So this is 8 to the power of 1, which is, of course, just 8, isn't it? So that's 1/8. 2 to the power of minus 5. Push it down, make it positive. 2 to the power of 5. So 1 over 2 times 2, so that's 4, 8, 16, 32. 1 over 32. Right, now this is already a reciprocal, so I'm going to show this power as 7 to the power of negative 2, right? These are a bit easier because they're already in index form. 1 over 6 to the power of 4, that's the same as 6 to the power of negative 4. Now 1 over 36. Firstly, let's write this in index form. 36 is the same as 6 squared. So I'm going to write that as 6 to the power of minus 2, all right? Okay, I hope you got that. If not, maybe just rewind it, listen to me again, see what we've got there. All right? Okay. Next. What about fractions that are raised to a power? We've kind of seen this before, but a long time ago. Now, I've got rid of the negative powers for now. I'm just going to do it with ordinary powers. What do we think happens here? Ooh, spoiler. Let's not have that. Well, if you've got a fraction raised to a power, that's actually the same as writing it separately. So 3 squared over 5 squared. Okay, you sort of square both bits individually. So 9 over 25 in this case. Okay, so there's our rule. If you've got a fraction that's raised to a power, you can write both the top and the bottom separately, each raised to that power. All right, your turn. There's 2 to do. Off you go. Pause the video, do them, unpause when you're done. We have unpaused. I won't make the dog joke again. Right, 1/4 to that's cubed. Well, 1 to the power of 3 and 4 to the power of 3. Okay. Well, 1 to the power of 3 is just 1 because 1 times 1 times 1 is 1. And 4 cubed is 64, so it's 1 over 64. I won't say anything about Zoo Lane. 2 cubed over 5 cubed. 2 times 2 times 2 is 8. 5 times 5 times 5 is 125. Okay, so that's just how you can simplify those. Now, let's do it with some negative powers. I know that's what you want to do. Well, remember what we said about the negative. You can think of it as one way is push it down, make it positive. But that only works if it's a single number. All right, like this one up here. Push it down, make it positive. But remember, I kept chucking in the R word as well. The R word was reciprocal. And reciprocal of a fraction is to flip it. So actually, for this, the negative flips the fraction. This is the reciprocal of that. And of course, 5 to the power of 1 is 5. 3 to the power of 1 is 3. Yeah? But, so there's our thing. If you've got a power that's to the negative power, flip it. Find the reciprocal of that fraction, literally flip it upside down, and then you can do that power thing with it. The top to the power, the bottom to the power. Yeah? So this one would be, firstly, the negative means that I flip it. So 5 over 3. And now it's to the power of 2. The power is now positive because I've used up the negative by doing the reciprocal. Now 5 squared is 25. 3 squared is 9. Yeah? Okay. Let's... yeah, give you a turn to have a go. Okay, so there's a couple for you to do. So remember, well, you know what to do. Go on, pause the video, off you go. I'll open my caffeine-free Diet Cola. Okay, we have unpaused the video and opened the diet-free, caffeine-free cola, whatever that is. And let's do this. So the negative means that I flip it, first of all. So it's now 4 over 1, and my daughter is currently stealing my caffeine-free cola. And that is now to the power of 3, because the negative has flipped it, so now we've got a positive power. So I can do 4 to the power of 3 is 64. That is a 4, honest. And 1 times 1 times 1, so 1 cubed is also 1. So actually in this case, the answer is 64. A quarter to the power of negative 3 is actually 64, believe it or not. This one, we're going to flip it first of all. So 5 over 2. And that's now to the power of positive 3, because the negative has gone because I flipped it. So it will be 5 cubed is 125. 2 cubed is 8. Yeah. Cool, okay. So, 4 more for you to do that are going to get a little bit harder as you go through. Off you go. Pause the video and do those questions, and unpause when you're done. Okay, right, it's negative, the power, so we'll flip it. 8 over 3, and the power is now positive. And then you can do these powers separately, can't you? The first one I'll write out in full, I think. 8 squared over 3 squared. So 8 squared is 64. 3 squared is 9. I'm not currently changing these to mixed numbers because I want to show very clearly just how we're using these index rules at the moment. Right, this to the power of negative 5. Well, the negative, remember, flips it. So a over 2. And now the power is positive, which will be, remember, we can write this out separately. So a to the power of 5 over 2 to the power of 5. Now a to the power of 5 I can't simplify, that stays as it is. 2 to the power of 5 is 2 times 2 times 2, so that's 2, 4, 8, 16. It's still 32, just like it was earlier. A to the power of 5 over 32. Okay, negative power again. You're getting the idea, right? So you flip it first of all. So y cubed over x squared. Now the power is now positive. Remember, when we got a power raised to a power, you multiply these powers together. So this will be y to the power of 18, because 6 3s are 18, over x to the power of 12, because it's 2 times 6 is 12. Right, last one. Bit trickier, this one. I noticed lots of people had trouble with this last time when I looked through Dr. Frost. But firstly, let's do it one step at a time. Let's flip it because the power is negative. X to the power of 5. And the power is now positive because I flipped it over. Okay, now this top one. Ordinary numbers, ordinary maths. So the 6 will be squared. It's not times by 2, it's squared. So it's 36. And then y to the power of 4 squared, where you times those powers together to get y to the power of 8, because 2 4s are 8. And then x to the power of, well, remember, multiply your powers, one power raised to another. You multiply them. So it's x to the power of 10. Right. Cool, get in there. Okay, we've got a couple more things to cover, and then you can go off and do the Dr. Frost task on the whole thing. All right. If you haven't got it, I do urge you to go back and just watch that section again. Otherwise, let's go on to fractional powers. I want you to use your calculator, and the button you want is that one, where you've usually got an X with a little thing, or sometimes the button might look like that on slightly older calculators, or occasionally it might have an X with a little Y up there for the power. All right, use whichever button it is, probably that one, to put in these. So 25 to the power of a half, what's that? 49 to the power of 0.5, 27 to the power of a third. Don't write 0.3, it must be a third as a fraction. And 64 to the power of a third as well. Pause the video, think what's happening, unpause when you know. Okay, well, hopefully you found that this one, the answer was 5. So what's happened? What's the relationship between 25 and 5? Other than you can divide it by 5, which clearly is not what this is. Well, 49 to the power of 0.5, this is a half as well. Well, that should have had 7. It is a square root, right? If you've got something raised to the power of a half, that half means square root. What about this one, to the power of a third? Well, you should have got 3. What's the relationship there? Well, that is not a square root. It's a cube root. So x to the power of a third is a cube root. So these bottom numbers are roots. This 64 to a third is 4. And again, that's this, 4 cubed is 64. 3 cubed is 27. This is a cube root. So these ones with a half are square roots. Notice the 2. These ones with a third are cube roots. Notice the 3. So this is what's happening. If you've got a power like this, the bottom number, if it's a fraction, is the root. That's what root you're doing. If it's a 2, you do a square root. If it's a 3, you do a cube root. If it's a 4, you do such a thing as a fourth root. We won't do those, right? But if you did, that's what you do. And then the top number is a normal power. And you do them in order, right? So, for example, hang on, oh, come back. Whoops. Where did we get to? Right, evaluate these expressions without a calculator. All right? So, it should be easy, okay? We know that a power of a half is a square root. It's not going to take you long, is it? Right? What is going on? Why has my computer gone absolutely stark raving mad? Okay, I think it's calmed down. Right, pause the video and off you go. Right, we've unpaused. I don't know why this 9 to a half has suddenly appeared up here. But it is, if you did do that one, it's 3 because the square root of 9 is 3. This is the same as the square root of 16, which is 4. This is a half again, so it's the square root of 81, which is 9. And this one to the power of a half, it's the square root of 121. Right? So there's nothing mystical about this. It's just a square root. The number, when you times it by itself, it equals that other one. God, dear. Evaluate these expressions without a calculator again. Okay, this is my example one this time. This is what I was hoping to do last time. If you've got something raised to a fraction, so this is the bit you need to listen to. I'm going to repeat that. If you've got something raised to a fraction, the bottom number is going to be a root. The top number is the normal number. Do the root first. It's usually easier to do the root first. You do the root first, then normal power. So, because this fraction has a 2 underneath, that means a square root. Right? So I'm going to square root my number, which is 3. Square root of 9 is 3. Now my top power is still there. My bottom power has been used doing the square root. The top power is now there. That's why you do the root first, because now I'm just doing 3 cubed. 3 times 3 times 3, which is 27. Okay, so do the bottom number first as the root. Put your answer, and then the top power is still there. You haven't used that. And then just calculate your normal power. So you do the root first, then the normal power. Same again here. Right. I've got a fractional indices, fractional power here. The bottom number is the root. It's in 3. So that means a cube root. I need to do the cube root of 8. Now, if you're not sure, you can do it on a calculator, but you need to learn these cube numbers. 2 cubed is 8. 2 times 2 times 2. Right? So I've used up my bottom power. The top one, this 2, that's still there because I haven't used it. But now I do it. I do 2 squared, 2 times 2, which is 4. Right? So do the bottom number first. That's your root, whatever it is. If it's a 2, it's a square root. If it's a 3, it's a cube root. Then, whatever your answer is, you do the normal power to that. Let's do it again. Bottom number is a 2. So what sort of root? Yes, a square root. Or no, this one's a square root, depending what you said. So that would be square root of 16 is 4. And then we'll do that to the power of 3, right? So you use up the bottom part. I'm trying to sort of say this again and again because it's really important. Use that bottom part of the fraction as the root. And then the top bit you do next. 4 cubed is 64. What about 10,000 to the power of 3/4? Right, now I said these wouldn't come up, and they generally don't. But let's think if they did. I want the 4th root of 10,000. Something that when you times it by itself, itself, and itself again, so there's 4 of them times together, you get 10,000. Well, that would be 10, because 10 times 10 times 10 times 10 is 10,000. So I've used up the little 4th root. Now I can do the normal power. 10 cubed is 1,000. 10 times 10 times 10. Right? So bottom number is the root. Do that first, and then do the normal power on top to what your answer is. Your turn. Thank goodness I can stop talking. Off you go. Did you pause? I hope you did pause. Did you do all 3? Well done, you. Right. The bottom number is a root. It's a 2, so it is a square root. So square root 25. And then we can do the normal power. 5 cubed, 5 times 5 times 5 is 125. This is a 3. So it is a cube root, the cube root of 27. Right? Again, if you don't know these, you need to learn your cube numbers. 3 times 3 times 3 is 27. So we've used up the fractional part of that power. We're just left with the top bit, which is the 2. So that's 3 squared, which is 9. This one, 8. The cube root of 8, because this bottom fraction number is a 3. So that means the cube root, because it's a 3, cube root of 8 is 2. And then we do the normal power. So this is 2 times 2 times 2 times 2 times 2, which is 2, 4, 8, 16, 32. It's still 32. Who would have thought it? 32. So do the root first, do the normal power afterwards. Okay, last bit. Now, we're just going to put it together. This is nothing new. You have done this already. We're just going to put together the bits you have just learnt. Right, do them in this order. We've now got a power that is both negative and fractional. Negative fractional powers, right? So we're going to do these 3 bits at a time. We are first of all going to deal with the reciprocal. We'll use the negative up, right? Then we're going to do, not the normal power, then we'll do the root. Then we'll do the normal power. So reciprocal, root, power. That's how it goes. Do the reciprocal first, then the root, then the power. Use up all 3 bits one at a time. Don't try and do it all at once. So negative first of all. That means reciprocal. So 1 over 9. Now I've used the negative, so my power is now 3 over 2. Right, I've got a 2 underneath. That means it's a square root because it's a 2. So we'll do the square root of 9, which is 3. I've used up that bit of the power. The only bit that's left is the power of 3. So it's 1 over 3 cubed. 3 cubed is 27. 1 over 27. Use the negative first to do the reciprocal, then work out the root, and then do the normal power of that. Right, reciprocal, root, power. Right, reciprocal first, because there's a negative fraction here, so negative first. So 1 over, and it's the same power, but now just positive, so 1/3. There's a fractional bit, there's a root. So we'll do that next. We'll do, it's a 3, so that's a cube root, isn't it? 3 cube root. So that's cube root of 8 is 2. And now the top power is just 1. So actually that is just a half. So reciprocal, root, power. Always that order. Reciprocal. Firstly, let's do the reciprocal. Let's do 1 over 16 to the power of, well, the power is the same. It's just positive. So 3/4. Right, the bottom number is a 4. So I want the 4th root of 16. Now you could use a calculator for this or recognize that it's one of the powers of 2. All right, and this is the 4th power of 2. So the 4th root of 16 is 2, which leaves us with the top power of 3. Generally, you get a lot of these where it's either a 1/3 or maybe 3 over 2 or 2 over 3. You get in exams a lot like those. Don't often get a 4th root. It would have to be either power of, fourth, like a power of 10 or a power of 2 maybe, Right, 2 cubed is 8, so this is 1 over 8, right? I hope this is really not too scary now. Right, we've got a negative, so we'll push it down. We'll deal with the negative first, so my power is now positive. Right, so that's reciprocal. There's no root here, there's no fraction. So I don't need to do the root, I go straight to the power. So 1 over 3 cubed is 27. Okay? So deal with the reciprocal, deal with the root, deal with the power. Your turn. 3. So pause the video, do those 3, unpause it, do the answers, and then we're off to Dr. Frostland. I hope you paused. I hope you didn't cheat. I hope you paused the video. Okay, here we go. Right, so a bit quicker then. So first of all, there's a negative, so we'll do the reciprocal. 1 over 25, and the power is now positive. I have a root here. I've got a fractional power, so the bottom bit is a root. Now it's a 2, so it's a square root. So that's 5. And then we put the last power on top. 5 cubed is 125. Next one. Negative. Okay, so reciprocal. So 1 over 27, and now my power is the same, but positive. So 2/3 again. I've got a 3 here. Got my little 3, so that's a cube root. Cube root of 27 is 3, because 3 times 3 times 3 is 27. My top power is still there. My 2 is still there. So now I use that. 3 squared is 9. Last one. Negative again. So we'll do the reciprocal. 1 over 8. And the power is the same. Just positive now, because I've used up the negative by making the reciprocal. We then do the bottom part of my power here. This number, it's a fraction, isn't it? This is a 3, so it's a cube root. Cube root of 8 is 2, because 2 times 2 times 2 is 8. And my last power is sat on top. So I use that one, 2 to the power of 5. So that's 2 times 2 times 2, etc. 2, 4, 8, 16. And what do you know? It's still 32. 1 over 32. Right. Reciprocal, root, power. Every time. Right. Ignore what it says on that little bit of thing there. It's fractional and negative indices as your task. I will be keeping an eye on this. I may even be in a live chat room in case you need to, live lesson room if you need a bit of help with it. But I want you to at least do a couple of questions before you come and seek extra help if that's the case. Okay, and then I can see what you've written and find out what you've done wrong. All right? Okay, so off you go. Well done. It's a tricky thing, but once you've got these in your head, they are stuck there forever, whether you like it or not. All right? Well done. See you later.